Okay, I'm handing these out today.
I feel like
Thought I did.
before and after.
I am fulfilling the great impersonation of the absent professor. What about you? Cool?
Oh, your finger won't be.
Well, I went with Carmen, Lily, Adam,
Here we go.
Kiddo, Coleman, Kid.
All right. As you can see, these really build upon the problems we've been working on, right? Or the same type of problem. And we're going to get through problem 17 on these today, and to be synced in with our 7th and 2nd period classes. So we should get through 17, I hope, pretty easily today. So what I want you to do is go ahead and work out problem 11. I'll choose somebody to help with problem 12, excuse me, in just a couple minutes.
Wouldn't it be
And if you take the piece of paper I handed back to you, it has those steps on problem 1 to show you the steps for multiplying together. And we'll put Julia back in here. Julia's back. And attendance. Everybody else too.
And then for the top to the bottom, where would you be?
All right. I'm going to choose someone here. And that someone is going to be, as we spin and spin and spin, that someone is going to be start out with Gabby. All right, Gabby, qu'est-ce que nous avons? Qu'est-ce que nous avons? What do we have?
First, you flip the reciprocal of the second one.
Okay, so you're just saying, like, if we do a rewrite, it's supposed to be 9, that's a 9, over 3x. So you're saying just change that to this, like x squared plus 2x
Yes, sir.
over x squared minus 7x minus 18. Okay?
And then I factored out the x squared minus 10x plus 9 to x minus 9, x minus 1.
So x minus 9, x minus 1, okay. All right,
And then over 3x.
3x.
Then the numerator on the second one, I factored to x and x plus, or bring out the x plus 2.
X plus 2, okay.
The denominator I have x minus 9, x plus 2.
Okay,
So then I mark out the x minus 9s and the x plus 2.
Okay,
So it simplifies to x minus 1 over 3x.
okay.
And then don't you simplify it, because you take out the x's, so it would be x minus 1 over 3.
Okay, any questions on that? Okay, and then we have our excluded values too, right?
So would it be x cannot equal negative 2, x cannot equal 9, and x cannot equal 0? Oh, and x cannot equal 1?
Yeah, as you said, 9. X cannot equal 0. What about 1? Can 1 be okay? Is 1 okay?
I wasn't for sure on that one.
Yeah, let's talk about this. Let's have class. Can 1 be is 1 an excluded value? Okay. Why is 1 not an excluded value? Can you have,
If you plug it in, it just,
It's not zero.
yeah.
okay, really what it is, the reason 1 is allowable is because your numerator can be 0, but what cannot be 0? The denominator.
Oh,
So it's okay, we can have a numerator equal to 0, right? Because 0 is defined, but dividing by 0 is
Undefined.
undefined.
Because if you have something divided by
Yeah, okay?
nothing, it's just take that word.
Yeah, it just does not compute. All right. Next. 13. We will get going on 13 here in a minute. So I'll choose somebody in another minute or so. Or 2 minutes? They're 2 minutes? 2 minutes? How much time do you need? 2 minutes?
yeah.
2 minutes. Okay, we'll give 2 minutes. 13.
Yeah. Oh, yeah.
Okay, we got another, got somebody else here? I'm spinning the wheel. It's slowing down, it's slowing down. It's going to be Bryce. Woo!
Just not good at all. Mr. G, you're gonna have to help me with this.
Okay, let's talk about this a little bit. So, if you remember what Gabby did, that could be very helpful to this. What was the first thing Gabby did?
She rewrote it.
She rewrote it. And how'd she rewrite it?
But on this problem, it'd be the negative 2x and the negative 6x, right?
Okay, she wrote this.
Yeah. You wrote the first one the same.
But what'd she do over here?
Look at the negative, or the positive 2x and the negative 7x.
Okay, what she did is this. Dividing by a fraction is the same as multiplying by its reciprocal. So we rewrite this as a reciprocal. And it's multiplied. Okay, and then what? What's the next step? And he doesn't have the paper that shows those 3 steps of multiplying together, right? If you look at,
Factored out the x squared.
so factors out, right? So she factors, and what does she come up with? Or what do you come up with factoring? What are the factors of this guy?
I'm lost now.
Okay, each of these things here, 1, 2, 3, 4, you try to factor them, right? You try to factor them. There are different techniques of factoring we've talked about. Greatest common factor is the first thing you look for. Factoring quadratic trinomials, there's one there and one there. So you have all kinds of opportunities, and I think, if I'm not mistaken, I think all these are factorable. 1, 2, 3, 4. So what are the factors of 8x plus 32?
8.
So 8.
Parentheses, it's in the bracket times, or yeah. X times plus 4.
Okay. And then factor this thing here. What are the factors of this?
X. Then it's x plus 4, and then x minus 4. X plus
Okay,
4.
there are no, what it is to get a negative, to get a minus a factor, you have to have negative signs someplace. I don't see any of those. You have plus plus. That's 4, right? Okay. Then we multiply by. Okay, Bryce, this time I want to make sure you do this one, Bryce. You do this one. What 2 numbers multiply together equal negative 24, but add together equal negative 2?
Positive 10 and negative 2.
10 and 2,
Well,
what
negative 2.
do you say?
Positive 12 and negative 2, right?
Well, positive 12 and negative 2 is going to give you a plus 10, right? We need a minus 2. So we need to get other factors besides 2 and 12. 6 and 4, so let's look at that. So we have 6 and 4, and they're 2 apart. So we're going to have, one's going to be 6, one's going to be 4. So which one's going to be plus and minus? we have negative 2x. So how do you get negative 2x? Which one's going to be, is it going to be x minus 6 or x plus 6?
Plus. Right. Minus.
Minus, okay, you can tell. You can tell because you have, if you have a negative number, the bigger number has to be your negative. Right? And then what's your factored form of this guy down here?
X minus, or, yeah, x, and then minus, right?
6.
6.
Okay, one thing you want to do when you look at this is, as you go and work on these things, you get clues along the way. Okay, let me give you a clue. You do this one up here, you say x plus 4, you ask yourself the question, wouldn't it be nice if one of these things down here happened to be x plus 4, right? And if you don't have an x plus 4 down here, then you would hope this over here factors to x plus 4. Because you're looking for opportunities to reduce. Okay, so now what can we do? What happens?
So then you reduce everything. Like,
Yeah.
you can get rid of the x plus 4, and now
X plus 4, and then
it would be, you would go to the other one, and then you get rid of negative 6, x minus 6 and everything.
okay.
And then you're left with 8. And then you're left with 8. Or
Is there anything left to cancel first?
other 2x plus x plus 4.
Okay, so now what do we have left?
8
8 over
x.
x. So that would be our simplification. What would be our excluded values? Okay, basically excluded values, what x cannot be. So we can't divide by 0. So x cannot be
0.
X cannot be 0, right? Because we can't have it be 0, that's good. What else can x not be?
7. 6.
X cannot be 6, okay? What else can x not be? Okay, we can't have this x plus 4 equals 0. We can't have x plus 4 equals 0, so what can x not be?
4 or negative
4 cannot equal 0, so x cannot equal negative 4. Can't have that either. Any other exclusions? And we've checked all the numerators and denominators. We checked this denominator and these two things here, and that takes care of all of them, doesn't it? Okay? Now, what happens is we get to the next little piece of set here, which is 14 through 17, which 14 to 15 brings back section 10.1, where we worked on adding, subtracting rational expressions. And then 16 and 17, so you're taking the same functions and adding, subtracting, multiplying, and dividing them, and just kind of compare and contrast what happens differently, how they look, your answers for them. So I don't know if you remember what you need to do when you add fractions and subtract fractions, with rational expressions that we did. What do you find that makes all that possible?
Common denominator.
A common denominator. Okay, so we find a common denominator, and so we'll say if we add these together, and I'm going to make up a function. I'm going to call that sum f of x. I'm going to call that p of x plus q of x. okay, we're going to add these together. So f of x equals 1 over x plus 1 plus 1 over x minus 1. So what do we have to find to be able to get a common denominator of this guy here?
If you multiply,
Multiply. So what do we have when we multiply together? What's going to be our common denominator?
x squared minus 1.
Okay, what it is, we have Jay's being an overachiever today. Well, I think that's good. And Jay correctly recognizes this is going to be x squared minus 1 if we go ahead and distribute, right? But which one's going to be more helpful to us? This one up here, the factored form. But yes, he's right. If you multiply these together, this is what you get, right? And then if you factor this in turn, you get this up here. Let's kind of stick with the factored form here. So we will go ahead and common denominatorize this first one right here. So what do you have to do to common denominatorize that guy here?
Multiply it by x plus -1.
And then what do we have to do up here?
It's the same thing.
What do we have to do up here?
Same thing.
Same thing.
And we add, and we have 1 over x minus 1. And what do we have to do to this guy? We have to go ahead and use x plus 1, or x plus 1. So now, just working across here, do we have a common denominator now? Yes, we do. So we have this one right here simplifies to x minus 1, and then we're going to say plus this guy right here. I'll say plus x plus 1. And all that is over x minus 1, x plus 1. So what's going to be f of x equal to in our final answer here? What do we get when we simplify the numerator? X plus x.
X should be 2x.
So it's
Yeah, 2x minus 1.
2x. And then we have minus 1
Oh yeah,
plus
just
1.
2x.
So we have x minus 1, x plus 1. Okay, so that's going to be our answer. And it says show how it results in another rational expression. Well, this is our other rational expression. And as Jay correctly told us, we could rewrite it as this, couldn't we? In the final form here, couldn't we? But we don't have to. So I won't. You can be an overachieving Jay if you want to do that. So I want you to do number 15. I'll call on somebody to work out number 15 here in a couple minutes. If you look at 15, it's going to be very similar to 14, except just changing it to minus instead of plus.
Well, keep in mind how we got that. So then you can do like,
-1 minus 1 or -1 plus -1.
is it really this square root?
If you don't find the y, then you can't find it.
Watch, I'm gonna get there. Oh, we still have. Who's that people?
I was done, I was looking at it. Negative 1 plus there.
Okay,
No. The other people haven't been gone.
next, we have, let me choose somebody. Help us out with this. Okay, we have this one,
I was following and then I wasn't.
But here's a one.
this one here, it's gonna be J.
Why are you laughing like you think I didn't do it?
It's not me.
Yeah, I think Kim was laughing because it wasn't her. I
Yeah.
think that's what I was, so I'm gonna defend Kim in this instance. Right, Jay, what do you got?
Okay, so I rewrote it as 1 over x plus 1 minus 1 over x minus 1.
F of x equals 1 over x plus 1, and then you multiply by
X minus 1.
x minus 1, and you subtract it out, 1 over x minus 1, x plus 1, x plus 1, is that right? Okay. And then,
Simplify that to x minus 1 plus x plus 1 over,
so x minus 1 minus
yeah, minus, not plus.
x minus 1 over all this right here.
Yes.
And so that's going to be equal to
Negative 2 over x minus 1.
fx equals negative 2 over x plus 1, x minus 1. Okay, does that look right? And it's, to me, it's kind of a little bit counter too, because you look at this, and you get 2x here, and over here, you get minus 2. Is that what you expected when you did it? Not me especially, but that's what it is. Okay, we want to do number 16, and we're multiplying together. So I'll choose somebody for 16 and 17. And that will be our class today. So we got, we have Kim.
Oh my God, no.
Okay, Kim. What do you think, Kim?
I do not think that you're right.
Just go ahead and write this out. So you got, this time, it's the same we've been doing earlier, except we got f of x equals 1 over x plus 1 times 1 over x minus 1. What's this one going to be?
1 over x plus 1. And then you multiply that by x minus 1.
So that's going to be it. If you want to get cute, like Jay was being cute, you have x squared minus 1, right? So that's it.
That's it? Oh, okay.
That was it. Okay, and then number 17. Okay, let's get one more victim today. This one's gonna be Marcus or Benny, Marcus or Benny, Marcus or Benny. It's gonna be Marcus.
All I know is you moved the stuff down, I don't know how to build it.
Is this a pen?
So here,
Is this third?
so here we have f of x is equal to 1 over x plus 1 divided by 1 over x minus 1. So how would you do this one? What do you do to this? What do you do to this guy right over here? Okay, so we're going to multiply by x minus 1 over x plus 1, and then multiply them together, you get f of x equals what? Let's see, this one here, excuse me, I miswrote it here. Yeah, so it's going to be that. So what do you get when you multiply these together?
1, then x minus 1, then 1x minus, then x plus 1.
That's it right there. Okay, that's it. So we're going to take up the word problems tomorrow, and that shouldn't take us all class period, but we'll see how it goes.
Sounds like.